This video provides a summary of AASHTO T315 titled Determining the Rheological Properties of Asphalt Binder Using a Dynamic Shear Rheometer, also known as a DSR. The DSR is used to characterize the viscoelastic behavior of asphalt binders at intermediate and high temperatures. DSR testing at high temperature is used to characterize rutting resistance, whereas DSR testing at intermediate temperature is used to characterize fatigue resistance. The DSR is used in other industries to characterize the behavior of polymers, cosmetics, and food. When performing the DSR test, the following safety precautions are required: safety glasses, a lab coat, closed-toed shoes, long pants, and thermal insulated gloves. The following equipment and supplies are required for performing DSR tests: a DSR, a spindle, a plate, silicone molds, a trimming tool, and a heat gun. The DSR test uses a thin asphalt binder sample sandwiched between two circular plates. The lower plate is fixed while the upper plate oscillates back and forth across the sample at 10 radians per second or 1.59 hertz to create a shearing action. The specified DSR oscillation rate of 10 radians per second is meant to simulate the shearing action corresponding to a traffic speed of 55 miles per hour. The software monitors torque and amount of rotation to calculate dynamic shear modulus and phase angle for each loading cycle. The test specimen is kept at near constant temperature by heating and cooling a surrounding environmental chamber. Test temperatures are determined based on the climatic performance grade of interest. There are two specimen sizes utilized in the DSR test: 25 millimeter diameter specimens with 1 millimeter height and 8 millimeter diameter specimens with 2 millimeter height. The specimen size utilized depends upon whether testing at high or intermediate temperature and the age level of the binder. Unaged asphalt binder and RTFO aged asphalt binder are tested at the high temperature performance grade to evaluate rutting resistance, which is most critical early on in a pavement's service life. Since the material is soft when unaged and at high temperature, the 25 millimeter diameter geometry is utilized. PAV aged binder is tested at intermediate temperature to evaluate fatigue resistance, which becomes more critical as the binder ages and becomes more brittle. Aged binder at intermediate temperature is much stiffer than unaged or short-term aged binder at high temperature. Thus, significantly more torque is required to shear the PAV aged binder at intermediate temperature to a given strain than the lesser aged binder tested at high temperature. The use of a smaller specimen reduces the torque required to reach a given strain. The following is a summary of the steps required for DSR testing. Heat the asphalt binder to be tested until the binder is sufficiently fluid to pour the test specimens. Pour specimens into the DSR silicone molds. Heat the DSR to the test temperature. This preheats the upper and lower plates, which allows the specimen to adhere to them. Zero the gap. Zeroing the gap allows the instrument to bring the specimen to the appropriate height. Each time the spindle is attached to the rheometer, it is in a slightly different position, and thus, finding the point at which the upper and lower plates are just touching provides a point of reference to allow preparation of a sample with accurate height. In zeroing the gap, the spindle is brought down to the lower plate until contact is established. The instrument knows when contact is established as it registers a normal force between the compressing plates. The instrument then raises the upper plate until it records 0 normal force. This is the zero gap position where the upper and lower plates first meet. Raise the DSR upper plate and place the asphalt binder sample on the lower plate. Lower the DSR upper plate to the trimming gap, which is slightly higher than the test gap. Use the spatula to trim the specimen around the edge of the test plates using a heated trimming tool. This step is critical as the DSR calculates stresses and strains based on an assumed sample height and diameter. Improper trimming can alter the specimen diameter and thus lead to erroneous records of stress and strain. Lower the upper plate to the desired testing gap. This creates a slight bulge in the asphalt binder specimen's perimeter. Start the test. The test will first allow the specimen to condition at the test temperature for 15 minutes prior to loading. Then, the specimen will be subjected to sinusoidal loading at 10 radians per second for 5 minutes. The DSR will output the dynamic shear modulus and phase angle. Test results can be used to assess the performance grade. For example, if an unaged binder is tested in the DSR and G star is found to be 958 Pascal and the phase angle is found to be 50 degrees, then G star over sine delta is 1251 Pascal, which exceeds the specification limit of 1000 Pascal. Thus, these results would indicate the binder tested passes the high temperature PG specification on unaged binder at 58 degrees Celsius.